start from scratch. I'll start from scratch just to complete some knowledge to people that missing, is to really explain the idea behind this model of neural network. But first, we need to understand what regression is, okay? What does it mean when I have several points, okay? Let's say I'm getting points like this one, and those points, I would like to draw a line that represent those ones. But we'll go, first of all, generate those kind of points that have some directions, could be a positive, going down, going up. And then what does it mean to try to estimate the parameters of that way of creating them? Let me explain that maybe to people that are not used to it, it might not be clear. Okay, so let's start. Okay, let's say that we have, let me start with the model. The model is that we have a straight line, y equal, let me just make it will not, y equal to a plus b times x. Okay, what does it mean? It means that for every x, we multiply by b, and then we're adding a to it. That's what gives me the y. Let's take an example. Let's say I have 100 points like that. I'll just make, this is like an index. We don't really use that one, okay? Let's say this is the index. Let's say we have 100 points, okay? Well, in a minute. I don't really want to use the index itself. Many times we do, but in this case we don't. Make 100 points. Exactly similar to what we have. Let's make just 100. Okay. And now let's write the parameters, the real one, the real life. Okay, we don't really know them, but this is just for the example. Okay. Let's say that we have 100 points. And the first point, the x, we put some x's here, and we'll put some y's here. Now, by the way, I'm generating them at random between 100, between 0 to 300. How can you do that? Okay, let's step by step. We take, first of all, 100 x's. What does it mean? I'm just generating some random numbers. I can do, there is a function called rand in Excel that basically, why it doesn't like me? I hope it's, yeah, it does. All right, see this number, by the way, it's a random number, okay? If I, you know, if I, you will see in a second, I will play with it, it will refresh, I'll give you different rand numbers, okay? I can, if I want, this is give me numbers between 0 to 1. I can multiply it by 300, so it would be a number between 0 to 300. Fair enough? So here we go, it's giving me 258. So I can take this one and generate 100 of them. By the way, if you double click on it, it will take all the numbers, we make numbers up to 100 because we have, I made the index up to 100, so he knows how to do that. That's Excel features. I really strongly recommend that you will learn Excel as well, whoever wants to be serious. So all those numbers are between 0 to 300. Now, what does equation mean? How the y can be generated, okay? How the y can be generated. Okay, the y, according to this equation, I will take the x, multiply it by b, and add the a to it. So let's make some parameters. Let's make some a. I will take the example we have here, and we do something similar. Okay, I just made an example here of a 280 and b minus 0.7. Okay, so let's make something similar to that. Let's make 280, the A and the B will be minus 0.7, 0.7, yeah. So let's make the A to be 280 and the B equal to minus 0.7. Okay, by the way, you see every time I click, those numbers are random, so he's always giving me random numbers. Okay, I will add a, later on I will add another parameters. Okay, I will add the parameters called sigma, but we'll get to that. Okay, we'll get to that. First of all, a straight line. How do we make a straight line? Very simple. We just use this equation that we have here. So we do equal, we will take the A, we will add to it, you know, F4 is lacking that cell, okay? And I will add to it the B, and I will multiply it by the X, okay? Here we go. So we're getting the value. So for this X, Y is that according to this equation. This is when the equation is perfectly straight line. Let's see what happened when we do that. So let's make a chart. Okay, I'm not expert on it. I used to be an expert on Excel. But let's make a chart of these two columns. Okay, let's mark them and make a chart. Okay, let's make a chart out of it. We can do an, sorry, I mistake. Okay, let's make a chart. Insert and chart, and we'll get that one. Let's make the chart to be scattered. Where's the scatter? Here we go. Let's do next. We get those fields. Next, we don't need to, and let's do finish. Here we go. You see the dots now, sorry. The dots are exactly on the straight line because we used this equation. We used this equation to generate those dots. Okay. By the way, a dot is represented by 2 points. This is the X and this is the Y. So a specific one, any dots here, so you have the X and you have the Y with it. It's a exactly straight line. Why is it exactly straight line? Because we really use this equation. But if I want to make the Y not exactly following this Y, I can add some noise here. That's what we call it. I will call it plus some noise. And the noise could be generated in randomness. What do I mean by that? Here we go. Let's say now this Y will not be exactly this equation, but we will add some random number. So we'll use a rand here again, but this one will be between 0 to 1, okay? Since those numbers are quite big, you know, we started from 0 to 300, that will not be exactly a lot of noise, you know? If I will multiply this rand by, let's say, I'll just make it 30 here. You will see one of those dots will stand out. Okay, here we go. You see this point? It's equivalent to the 86 here and to the 200 something 30. So it stand out a little bit because I added some noise to it. It will stand out, okay? But let's add another parameter. I call it sigma, okay? By the way, can be estimated as well, but that's not the objective of this exercise. Let's put it this one 30 and then change all the numbers accordingly. So I'm going to go back to here. Instead of just putting 30 here, I'm going to utilize this cell. It will be the same, okay? So it's a standout point right here. Let me give it a bigger number so you can really see it. Let's put a 50 here, okay? Yep, it disappeared. What happened? Hold a second. Let me F4, bingo. Here we go. So you can see this point is standing out substantially. If I make a big one, let's just make another big one. So you can really believe me, this one is affecting it by removing it from the element. I will change it to 80 so you can see every time you, here we go. It's standing out. Let's make all the point. I will add this one to all the points. This one we didn't have. So we're adding it to all of them by double click here. It will copy down. Now it looks like going down and all the dots, they're not exactly on a straight line. If I put this one equal to 0, it will be exactly straight line, okay? The more I change this one, it will move the points away from that straight line. Fair enough, so far so good, guys? If I put 30, it would be kind of, some things we do here, by the way, on this program, we just use Python and JavaScript here. I'm utilizing the sigma here of 20, and it will make those dots not exactly on a straight line. Fair enough? By the way, if I want to put here a small number, I'll put 0.1, you will see it will be very close to a straight line as well. Okay, you see, this is really almost straight line. Okay, very similar. So this one is doing exactly the same things as we're doing it on Excel. But the beauty here is, of course, using Python and doing all the model, which you can already do with Excel. You don't really have the capability to do it on Excel. Okay, so we got and understood what this one is about. What I would like to do now is really, what are we trying to do? Okay, what are we trying to do? Pay attention, those A, B, and sigma, those are parameters, okay, that they are making these lines. But in real life, you really don't know this A and B. You try to estimate it. In another word, I would call them A hat. That's what we're trying to estimate, okay? And we will have, let's say, and B hat, we're trying to estimate. How do we try to estimate it? Based on those dots. So according to those dots, we're trying to find out A and B such that the line that this one will make would be very close, okay? And we're really close to all those points. What do we mean by all of that? How do we do it? Okay, you know, how do we do it? How do we do it? So here we go. We have the x's, but this time, it's this one we know. This is the real one, okay? This is the point, okay? But what we would like to do is trying to build up a y hat based on some, let's say I'm guessing, okay? That the A is 200, it's not the right, I don't know. You know, I'm in the beginning, I have no idea what the real one, that's a real life. I only have those dots. You know, Excel is a little problem, is always will change. There's a feature that we make in Python that I can tell him, give me numbers, but every time I ask random numbers, don't give me really random numbers. Give me the same numbers for the training when I'm studying something. Eventually, when I want to test, I will make some random numbers. I will get to that feature. It's a beautiful feature for research and training. Okay, so let's see. Let's say I don't really know what the alpha, I'm just guessing, taking some random numbers. Let's say I take minus 0.1, okay? How the line will look like. So let's, I don't know, do you know how to add a line as well to the same chart here? I don't really know. I know how to do it in our system, but I don't really know how to use it in Excel, but I don't really care. I'll make another one, okay? This one, I'm gonna build up, okay? I'm gonna build up now the Y in such a way based on those parameters, not the real one, okay? This one give me those dots based on that, but here I'm gonna make a straight line based on those one. I'm not gonna add noise, of course. So let's do it. So what is the first point here gonna be? Based on this X, but according to the equation that used this one. So let me write it down here. We'll make a y hat, a y, that will be depending on the A that I'm assuming for the beginning, and eventually I will change those A and B such that the line will be as close as possible to those points. You know, if this is confusing, don't be discouraged. Believe me, it is confusing, especially when you're not coming from this field. Eventually, you will get it out, you will figure it out. So now I'm adding a B, so I'm getting the B head and multiplying it now by this x. Okay, pay attention to the difference between, okay, sorry, yeah, I mean that. I'm going to use that x in a second. So how do I do that? Go to here, and I'm going to do equal to this a plus, let me just make sure I will fix it. And then I'm going to do the b and fix it. And then multiply it by this x. I'm getting a point. By the way, now I'm going to take this one for all the 100 points. Now, everybody knows this one we didn't add any noise, so this is going to be a straight line. Fair enough? This is going to be a straight line, but this one is not going to be very close. By the way, this is 200. The real one is 280. This is only minus 0.1. This is, let me show you what this one means. No, you know what I will do? Anybody knows how to make a straight line inside this one? I have no idea. Anybody knows? I don't really know how to do it. I know how to do it in Python and all of those. I used to know. I don't want to waste my time even. You know what? The hell was it? But this is will give me a straight line. You know what? Let me try to do that. I tell you what I will do. Just to convince you. Okay, let's use this one as the x. I will duplicate the x in here so they will be next to each other. So you know it's the same x. I'll take this one. And so that will be always the same. And let's copy it up to here. Now we have those two films. And let's make a straight line. Let me try my luck. Maybe I'll be lucky. Let's see if we can add a data series in columns. Can you add to it something here? I don't know how to do that. Okay, forget about it. Let's add another chart here. Okay, let's add another chart here. This one would be a straight line. And we do insert a chart, and we get that one. We made a straight line. You want a line now. It will take that line, you will see it. I'll make it scattered because they are already scattered, but it will be really almost exactly on a straight line. Finish, and here we go. Okay, so you can tell that this one is the dot we generated here, and we added some random to this equation. And this one, by the way, why I'm getting here, that doesn't make any sense. 155. Yeah, that's fine. Let's play with the numbers here a little bit. Let's make this one 1. Let's see what happened. Yeah, here we go. You see, based on these parameters, this straight line will change. If I write here minus 0.5, I'll get a chart like this. And by the way, if I use the same parameters, it would be almost the same. Just this one would be, all the dots will be on the straight line. Let's put here 280. And let's put here minus 0.7. Okay? So we're getting here dots on exactly straight line. This is the dots that they are that they are that they are generated with a random, that we're adding random and don't put all the lines on this timeline. What the challenge we're trying to do now? We don't really know those ones. We don't. We can guess them. It's like I'm hiding these ones. I can hide this one. I don't really know these ones. And I'm trying, by knowing these numbers, to try to find out what really the underlining A and B. Okay, that's the exercise. How do we do that? How do we do that? Let's just assume we're having some stupid numbers here. Let's make it let's make it 100. And let's make here, I'm just making it 1. I don't really know how the line looks like. Now, how do we know that this one is really not a good one? So here is the index we're developing. This is the method we're developing, okay? I'm gonna add here some, okay? And what happened? Okay, let me just move those one. How do we know that this one is not the right parameters? Because if you take the points here and compare them to the points here, okay, they're far away. Those points, they're quite far away. If I have it here 280 and here would be minus 0.7, those lines are as close as possible to those ones. So we're trying to now measure the distance between those points here to the points here, and we're trying to move those such that the difference between them would be the minimum. That would be our best finding of these A and B. So let's do again. Let's put here again 100, and let's put here 1 just for the example. And now what do we want to do? We want to measure the difference between those points. So if I take this one to be, let's call this one to be y hat minus y, and we square it. Take the difference. So it doesn't matter if the point is above or below. If we square, it will always be positive. That's what we're going to do here. So we take this y, we subtract from it this one, and we square it. That's for the first dot. We take it for all the dots. We double click. Oh, wow. So we're getting all those the differences. And let's sum those differences. That's what's called a mean square error. That's what it means. I'm taking the error, the difference between this equation we're estimating and the real ones, okay? Okay, those the dots that we have, this is what would be our estimate kind of, or what we're guessing based on this equation, but we don't really know the A and B. That's what's missing. We need to find the best one. What does it mean, the best? That's what we're trying to find, we'll see. So we're taking the differences between those two y's, we square it, we do it for all the points, and we add them up. So we do sum here. And we add all of them. Bingo. Now we got a number here. Okay? This number, I won't put it here. I'll put it there so we can see it because we're going to play with it. I'm going to cut it from here. I'll just put it here so you can appreciate what we're doing. I'll put it here. Okay? That's what we call square root. Square. Well, you know, you can take a square root. I mean, you're taking that, you power half. It doesn't make a difference. Let's just call it square. It doesn't matter for our purposes. Okay, this is the square. I would just call it square like that. Of arrows, square arrows, let's call it. Fair enough? Now, we want to find A and B such that will be the lowest. You know, the lowest, when this is get low, 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 that means we're really getting close to the real one. It will be a line. Pay attention to when I change this, let's say even to 200, watch this number. Make it big so you can see it, okay? In fact, the beauty about the Python and JavaScript, the whole thing is done automatically, beautifully, and you can see the chart. We'll do it in a minute, okay? If I would change that even to 200, closer to the real one, you will see this number will go down. We have 2,600,000. If I put 200 now, bingo. In fact, it went up. Do you notice it? It did go up, isn't it? No, did it go up or down? So it should go. How much do we have here? 2 million. So this one will be higher even. Okay, so this is not the right direction even. Let's move this one to minus 0.2. Oh, it went down now. So this is, you know, so what the computer algorithm does is start playing with A and B until this gets to a minimum. Okay, so let's continue playing. Okay, now how do I know to increase, decrease? That's called a gradient. I won't get into the mathematics of it. Okay, you can guess which direction you should go. Pay attention. If I do minus 0.3, okay, it might go down. Okay, well, it went up, so I should really go to another direction. It will go, let's make this 300. Does it get it smaller? Oh, wow, big time smaller. You notice that? 500. Let me go back. 200. Okay. Pay attention to this one. Let's make 201. Okay. Pay attention. This will go down probably a little bit. Okay. Let's see. No, so it means I really need to decrease it. That's really what it means to me. Okay. So let's continue. Okay. Let's take this one minus 0.4. Oh, went down. Let's go. 0.5 and negative. We want negative here. Negative. We're realizing the negative giving me lower numbers. Okay. Let's continue. Let's do here 0. Let's put 0.7. What happened? Okay. And I still continue looking. What about 280? If I put the exact numbers, oh, I got very small number, 29,961. By the way, this is supposed to be the lowest number, okay? Close to the lowest number you can get. If you make that one 300, it will be a higher number, okay? Let's make this one. Let me see here. Am I having something wrong here? I'm making a mistake here somewhere? I don't think so. No, I'm okay. So eventually, I'm trying to get a number. So this one will be the lowest, and that will be my estimate. Fair enough? Now, this is doing it in Excel, probably not the right way to do it, but this is beautiful to explain to you what we're doing. Let's go over the steps. We're in real life getting this data, okay? For the example, we generated this way, so we know what we're doing. But ما يعني احذرك بالشيوخ. So this is what we have in real life, okay? And we look at those numbers and we try to fit a model, and we try to estimate the parameters of the model. This is our model, y equal to a plus b times x. We try to estimate those such that the line here will be as close as to those points, okay? So we're trying to find something that will give me, so this line will be as close as possible to those points, okay? Now, the way we do it, we build up the model, and then we start changing those parameters until this square root will be minimum. And then we say, this is my estimator. That's the process. Please pay attention, okay? We have dots, we have the sample. The sample, we feed to it a model, and we try to change the parameters. We call them weight in AI, known as weight. And those weights, we try to find them until this will get to a minimum. Let's see what we're doing here, okay? I want to give this one because I already trained it. We go on my computer. I'll do it on my computer. This one I want, okay? So let's see here. We'll come back. Okay, let's take an example. Here we go. We have 280 minus, let's generate data, random data. Okay. It doesn't like me. My computer off. Yeah. I have those dots. Fair enough. I'm getting those dots. I want to fix on those ones. I will start from a clean one. I will train the model from a clean one. And then you will appreciate what it does. It will take some time to train it. So I will just show you the beginning here, and then I will move to the server because on the server I already have done it. Okay, but let's understand. I want to train the model. Okay, how do we train? What is the algorithm? How it does it? I will go over with you. But basically what it does is really does like we did in the Excel. It's changing those A and B in a way until it gets to the closest possible. How does it do it and how do we do it? So on the programming, I will go over right after I show how does it do it here. Step number one, I'm running and I do training, okay? Is doing and learning, it sees the difference, is trying to fix, it takes a random A, random B as the first time, and it's trying to make a line. And that line, it will append it for me, and then we'll see that here we'll append it on the same one, okay? Bingo. Yep, I don't even see it. Oh, it's running. Takes him a little. I don't know why it takes him so long. Yeah, here we go. Yep. Now I don't even see it. Why I don't see it? Because, you know, the A is almost here. You know, you might see a dot here. You see maybe a little dot here. And it has a negative slope. So you don't even see it in here. I'll give it another, maybe give it 1,000. 1,000 it will be, it's still, maybe it'll give me a beginning so I can at least see the wrong line. It continues searching for A and B to be close to those points. It's still running. And I want you to pay attention to this chart. Oh, here we go. It found a line, but definitely this line is not good. Okay? This line is not good. It's not really representing those ones. Okay? And what do we see on the right one? The first, you know, I ask him 100 times first and then 1,000 times. Every 100, it tells me the square root. What are the square root? So the first time was very high. It changed the parameters such that that square root will go down. It will continue doing it until it will fit it. It will get better and better. Okay, if I ask him, do another 1,000, well, it will take him about 100,000, so it will take a little time, so I won't run it here. I did it already on the server. Okay, on the server is extremely fast. My computer is quite fast, but see, the beauty here is training and training and getting better and better and better. And here you can tell you're getting those parameters. The A is getting a little positive, more positive, and this one should be really getting a little lower, lower. Let's do another 1,000. I will do a few of them. So at least you will see the progress that is going. Then I will show you the last results as I did it on the server. Okay, okay, it's getting, but it's already enough for him. You know, it's still. Hold a second. No. Let me do that. Now it will improve. Sorry. I was improving. You know, when I'm starting from scratch, I put continue training. If I said no, it will start from scratch. Here we go. He's improved a little bit, but still. And how do you know that he's improving? Because those dots is going down, meaning the square root is going down. Let's try another 100, another 1,000. I will explain what does it do, really. It's a really sophisticated algorithm. It's called a gradient. When A randomly picking up those A and B, it's not just changing them randomly. It takes a derivative, you know, some mathematics of a function. It sees how much this mean square changes when you change the A and B. And if it's reducing them, you will move the A to the same direction. I will move the B to the same direction to reduce the mean square. That's called gradient. How much it will reduce the mean square, I will define gradient for you for easy way. I have A and B. So how much the mean square will go down if I move the A a little bit? How much the mean square goes down if I move the B a little bit? Okay, and it will move it to that direction. What does it mean direction? It will increase A if it will reduce the mean square. It will decrease B if it will, in fact, the A should increase it because the increasing in A, it will give him a smaller mean square. Decreasing B will give him small. So when we're training, pay attention to another one. Let's do another one. You will see we got the right direction. He knows this gradient, how does it change, but how do you do it? I won't get into the mathematics. It's beautiful stuff. But say he's going to the direction. He's increasing A and decreasing B as he goes along. And he will do it until this one will be very close to all that point. The mean square will be very, very low. And you can tell every time he's training, this mean square going down, very close to what we did manually, not very successful, but is reducing this number as he's changing those parameters. Fair enough? So I will do one more, and then I will move to the server so you can see how they really did the whole things. And I would show you, he ran it a lot. I ran it a lot, and it runs very fast on the server. So here we go, we ran it already 4,000, almost 5,000 times. Okay, and it gets better and better. Let's look at the server. Same example, I uploaded it to the server. So let me run the training, and you will see, it will show you the exact, almost very close to the real one. You can tell he's found out that it should be 280.56 and minus 0.71. This is very close to the real one. Now, what do you see in this chart here? This is exactly the mean square. Let me make it bigger so you can see it. Okay, it ran almost 8,000 times. And you see, in the beginning, is improving a lot because it's getting closer and closer to the line, the point. And then eventually it gets to the point, it really almost doesn't improve because it got very close to the real one. That's when you stop. By the way, there are a lot of topics that when you teach an algorithm in AI, some people, there's a phenomenon known as overfitting. You know, if I run it too much, it might start getting out of this point, but that's another topic we'll discuss. We'll talk about it some other time. I will go to the code a little bit, but before that, I put a picture here. This picture really shouldn't be that way. This picture should have only one line here. This one, you should delete them, okay? Because we have only an x, one x. And this x is multiplied by the weight. Remember I told you the A and B called weights? So this, the number x, whatever each point has an x, it's multiplied this weight by the B, really. And then we add the A here. That's called a bias. Okay, we'll cover that more and more as we go. Our next example will be much more complex than that one. Here we have only one. Our next example for next week, or maybe even after if you need more time on this one, okay? In this example, we'll have 784 parameters. This becomes to be real AI, okay? We'll talk about that one. And in fact, here we will deal with handwriting images. Let me just show it to you. I already trained it. If somebody write by his hand a number, can the computer with the algorithm, read the number, read the picture, and predict what number it is. Yeah, it says it's 4. Let's get another random number. All right, 9. It does recognize it as a 9. It's beautiful. How does it do it? Very similar architecture, but this one a little more complex, much more complex. Okay, but the idea is very similar. There's one more point, and we'll see this is one way to do it. There's many ways you can do it with more complicated and more accurate even, but let's stick to that one for now, because we got all the main point, which you really need to, when you do AI, okay? When you do AI, you really want to get the ideas and they're repeating themselves. One thing is, okay, I have the sample. This is only the dots. From those dots that I'm observing in real life, I'm fitting a model, in this case, with, it looks like that they're going down, probably a line can represent these dots. So we assuming this is a straight line and we try to fit. We are fitting a line into those dots. And then we tell the algorithm, take those dots and find the parameters of the model, which is A and B, such that that line will be as close as possible to those points. Okay, please go over this video, listen to it many times, and try to absorb those concepts. As picture-wise, you have a little picture. I don't go into this one activation. We'll talk about it some other time. In the next round, the next example, we talk about what this activation function. We don't really use activation function. In fact, we do use, but the activation function is really redundant. It's a y equal to y, which is really a straight line of 45 degrees, but we don't really actually using activation here. Okay, it's a straight line. But we'll get to this concept more and more until you really absorb and what does it mean. But this is a beautiful picture that I put here for you guys. You can look. So when we're training it, now let's look at the code, please. I think I mentioned it several times in the past. You know, if you're really serious, I would contact SEO and Opio and take their course. They are very good teachers. They are very good programmers in Django, in JavaScript, Python, and databases. Believe me, you really need those classes unless you're already expert. Okay, we have a beautiful framework. If you look at this framework, okay, we have built on top of Django a lot of beautiful stuff which can help you to program. By the way, all the code this is a system we develop in Academy City. Let me just be clear. So I don't really have any motivation to encourage. The only motivation I want you to succeed. I don't take any money. You can ask anybody. Everything I do is for free because I want you to study. You'll ask, hey, why do you do that? Well, thank God. A lot of people help me in my life. It's time for me to help you guys. But I think if you're smart and you learn those classes with EPO and SEO, you will improve and maybe even join them one day and enhance this learning. I don't think there's any place in Uganda that carry those kind of classes. Frankly, I already been in Uganda many times and I have been involved with people. So be smart. You know, this is really one of the best way for you to search out on do beautiful stuff, which is the future. You are young, take advantage of it and learn it. Okay, let me go into the code. The code has two parts. The JavaScript. What the purpose of JavaScript here? The JavaScript objective is to communicate between this interface. You know, we're putting parameters here. You see, if I change this one to be 2, it will give me, I would just make dots now. It will give me dots of a straight line going up. Why is the, I changed the B. Let me make this one 10, and I will make a straight line. Here we go. By the way, the beauty of it is let me make it even 1 here, so it will look like a straight line, 45 degree. Now, what does it do really when I do that? The JavaScript takes the parameters from the screen that I type in. When I click on the button, it will activate a function in JavaScript, will take the parameters from the screen and send it to the server. By the way, I'm sitting here in Netanya on my computer, but I'm not working on the server. I'm linked to the server because I'm using Academy City, like you do, from home, okay? You can play with it, by the way. You can play, you don't have that one when you log in, because I log in as an administrator and I can control the coding. But basically, when I click on this button read the data from the screen, send it to the server, which has Python. The Python has the code to generate, 100 points, because I tell him here, give me 100 points. It takes that parameters, generate those points, and send it back to the JavaScript. The JavaScript receive those data and make the painting here. So this one is being painted by JavaScript. On the other hand, the one that's generating the dots is Python. And how do I communicate between each of them? We utilize Django, but we enhanced it even better. We developed this framework, and the beauty of it, if I want to see the JavaScript code of this button, I just do Control-click. Okay, and here we go. This is the code of JavaScript. This is the code. By the way, this one, just telling, ask me if I really want to activate it. I can delete it. Here we go. I'm going to delete it for a second. Okay, and I will click here and refresh. You will see now, there won't be any message. I won't get a message now. It will just give me the dots. Okay, you see, it didn't ask because I deleted that code. Okay, otherwise that's not helpful, so I can leave it. But what is this code about? What does it do? Okay, is in fact using JavaScript and sending all those parameters, taking all those parameters from the screen and sending it to Python. How does it do it? Well, you can go and spend a lot of time studying Django in the regular way, and you spend, but we have developed a system. We're generating a JavaScript general object. By the way, this one, it's an object we created here. It's a JavaScript object. And we know how to communicate to this object. This object has a structure. You can study this structure with Opio and SEO. They're very good at it. In fact, they're, sometimes I need their help to help me, honestly, because you forget. And by the way, a good rule of thumb on programming, always program with a friend. Don't do it yourself. You can miss stuff easily. And when you work with someone else, it's always good. And I really strongly recommend. I know them for at least 4 years now. I think even more than 4 years. And I can vouch for them, okay? So anyway, these objects has a function train. And this one basically have a way to communicate to the Python. And by the way, here is really, I give it the parameters to which object, there is an object here called NN data processing. This is a project, it's an object in Python. So JavaScript sending this to Python, Python receive it, and is generating an object on Python. When it gets to Python, he does whatever function I'm asking him. So if I'm here, what I'm really asking him is activate a function called train. And this train, okay, which is basically is going to activate this train function on here. And this one, is adding here that on Python, use this train function inside this object. I won't get into all of that. It's a lot too much for you to absorb. I just giving a little structure. And if you really, I really strongly recommend you do. So basically, when I click on this button, I'm really going to a JavaScript. Since it's a server, let me go into my computer so I can really demonstrate it to you on my computer and you'll be convinced. Okay. It's the same structure on my computer and on the server. It's exactly the same. We always do it on our computer first and then put it on the server. So when I click here, okay, we have this message that I had before. And this one goes to the Python. Let's look at the Python. Let's see. I said this is going to this object, and the object is NN data processing. Let's find it in Python. It looks complex first time, but when you get used to it, it gets very easy. We have a project called machine learning, and under that, we have all those one. By the way, this one is sitting here, and we have this project. I know how many of you know already Python. I really hope you do. This is also a structure we made in Python. By the way, if you learn the structure of those two objects, you can do so much, okay? Because there are already many functions we added here in Academy City, which help you to work with Python in a very efficient way. On top of Django, because Django is a beautiful framework. You can read about Django, okay? But here, we made a structure. So here I put a train function. So here we go, just to convince you, let me put this line. This is gonna print something, okay? We usually put a number here so we can see that this function is. If you look at the printout here, it does print it's here. But you know what? I will do something else. I'll print those dots when it gets out. Let me just show you this one. We have the data. So let's print this one so you will be convinced. We'll see a lot of numbers now. We'll print this result. Then after it does it in Python, he's sending it to the JavaScript. JavaScript get those data and point it to the screen, okay? So let's see how that does, okay? That will be a good example for you. Let me just click it again and do yes here. It's sending it to Python, okay? It says running, it got it. It's not estimating anything because I put that one. When I click on train, it will give me this one. So let's see what happened on here. Hold a second. Am I in the wrong place? And how come? Oh, this one should be. 1 second, sorry. Apologize. Machine learning 50. How come I'm not getting anything here? That doesn't make any sense. Thought I did. I know why. This one will be right for when I do the training. But let me, in the training, there is stopping in the middle. Just click, here we go. If it's only for that one, we'll do it here. So let me put it here. Okay, you'll see it now. Okay. Okay, let me click it again. Yes. Take him a second. And here we go. Here we go. We got all those dots. This is really the X and the Y is generating, okay, 100 points, meaning we have an X with a list for 100 of them, and then you will see the Y. So those are the X and the Y. You can think about this X and the Y in Excel like this X and this Y. You see that? So when I get this X and Y, the JavaScript receives those from the Python, receiving this from the Python in here. By the way, this is the function that does it. And we get the data from there. Okay, you know what, let me convince you so you'll close the circle. Okay, here we go. You know what, let me show you this one here. I think that's what show you in JavaScript. You know, Python sending it to JavaScript. When I click on it, I do yes. First of all, it's doing it on Python. And this is giving me only those two dots. That's not what I want. I do it again. I can't remember my code, but we'll fix it in a second. Yeah, that's not what I want. I want to show you the X and the Y that coming from there. So let me find it. I will find it in a second. Bear with me. Here we go. I'll take this one. I'll put it on the top. okay? Because this function is getting called and is being transferred, the data that coming from Python, okay? And I will just get the data is the coming back from Python, okay? And let's refresh again. And let's go back to this model and click on this one. It goes to Python first. Okay, hold a second. And from Python is coming to here, okay? All those numbers, by the way, remember 1, 1, 2. You will see this is exactly the data on Python. Here we go. It will be, here we go. This is exactly this number, okay? From Python, the one that generating the number is Python. He's sending it to JavaScript. JavaScript get this one, and in this function that I just was playing with, painting it here. So the canvas, you need to know how to work with a canvas, how to make a chart, and we did all of that work, a lot of this work. Just go and study. You're smart if you do that, in my opinion. Okay, so what did we do today? We've been exposed to the structure of how to take some observation. This is what we call also observation. We try to fit it a model, okay? And we learn how from JavaScript, we give command to Python, okay? From Python, it goes to the server gets the instruction, give me dots because that's what I'm asking him, is generating those dots and send it back to me, JavaScript printing it. What we will do next time, I will go into detail. How do we, the mechanism of finding this A and B such that this will be minimal, like as we did before, when I click on train, okay, it will do the training, it will utilize a model. This one is done in Python, okay? And that's what we need Python, okay? So if we go into here, let me take that one, I don't need it anymore. And you will see that I will just show it. I won't get into it next time, we'll dedicate time for it, okay? You will see we have create model function. We'll talk about this model. How do we translate of what I just was talking about and what this one resemble, this picture that we have here. Why is my, a second, let me go back to the server. I just put the pictures here, okay? How this is resembled, okay, we call that the layer. Next time when we talk, the one after next time, maybe we'll start next time. What those ones, we call those layers, okay? And they have a structure in Python and libraries. There's few libraries, I will talk about them next time. TensorFlow, Keresa, and all of those ones, they help you out to structure it automatically. And we'll talk about them next time. So this one, it's a very simple one because we have only one layer with only one element. I'll just show you, so you, but next time I will spend the time, you'll see here the number one telling you that we have only one. If I have four, I'll just type four, and then I have four variables. But we'll talk about it next time. It always will be a good structure. I will also teach you how you can organize your AI project in a smart way. We'll start next time. So create model will have in a lot of projects, okay? We many times will have generate, this is only when we don't have data and we're generating them. I will go over it next time. A lot of advanced topics, how you save data into the hard disk and read it back. All of those we'll do. This one, by the way, remember, I told you you're fitting the model, meaning we're looking for A and B, so it B is fit as much as close to those dots. We'll talk about it next time as well. We talk about the loss function, we call it loss, but the mean square, it's known as like the distance. The more is the distance is big, then it's like we're losing. The model is not a good one. But this one we try to minimize, and then we talk about the whole thing next time. We'll focus on Python next time. Okay, question, guys? Anybody? Okay, guys. sur le rhizome.